Hello, this is Jeff Schneider with Transcend Computing. Today we're going to talk a little bit about middleware, platforms, and PaaS, and the evolution. First, just a little bit of information about who Transcend Computing is. We are an organization that has implemented a clean room implementation of the Amazon Web Service Stack above the IaaS line. So what that means is we've done clean room implementations of things like Elastic Beanstalk, Elastic Load Balancer, Relational Data Services, Elasticache. We make these for use on your private cloud, or if you choose to put them at another cloud of your choice, that's fine too. Just a quick discussion on what we think of as PaaS. There's a lot of confusion in the market, and I don't know that it's been cleared up. But here's a complex slide to clear things up. What we're looking at is an example of a database as a service where we're showing two different endpoints that are managing two different clouds but across the same service. These are running in HA pairs. Each database as a service endpoint is responsible for managing a bunch of platforms of the same type. In this case, again, databases. This is one pattern. There is another pattern where you don't actually have a bunch of little databases or small instances of whatever, but the implementation is actually hidden or encapsulated. This is typically the case when we have a multi-tenancy based PaaS. And a good example of that is Amazon's DynamoDB. But some of the common features we typically see in PaaS are, number one, it is called as a SOA call. It is a service. It runs remotely over the network, consumes CPU, memory, storage, etc. of some other machine. It's very common that there's a provisioning or deprovisioning of a platform, especially if it's a platform that's exposed to the end user versus one that's hidden or encapsulated. The PaaS typically does provide some level of authorization and access control. It's common for the platform to be auto-monitored, and if the monitor is saying that something has failed, that the monitor notifies the platform to restart it and automates the recovery. It's very common to have auto patching and maintenance during a maintenance window. If applicable, many of the platform services will also scale themselves up or down based on the amount of usage. Many users want to put in throttling or also have metered billing, so we're watching the amount of resource usage that's going on. And if we're in a multi-tenant environment, we're trying to protect against noisy neighbor situations or potential security situations. The next big question is why PaaS? Why do we think it's the next big thing in application development? So on our last slide, we talked a little bit about the automation of manual tasks such as backup and restore, healing, scaling, and patching. These are very useful features. They're perhaps even more useful to the operations group than they are to the developers. And obviously the person who's writing the check to pay for all of this is going to be happy that they've reduced long-term maintenance costs as well. One of the reasons that we see people getting started with PaaS is because it's typically cheap. It's often pay-per-use. You can start off with a very minimum amount and then scale out economically. The good PaaS solutions also allow us to swap out individual services. What this means is that you can do a try before you buy. So we see application teams identifying those architecturally significant components and pushing them to the front of the development cycle. An example might be the team thinks that they want to do a NoSQL database, but they're not sure if they want to use Couch or Mongo or Cassandra or whatever. So they quickly provision each one of these, test all of them out. This is the architecturally significant piece for them. They determine which of the choices they like the best and stuck with it. They didn't have to go through all of the pain of installing each one, getting each one configured, and so on. So that kind of gets to the next point of, although we love DevOps and we love some of the DevOps scripting, there are certain cases where PaaS allows you to avoid some of that. And many view PaaS as a great way to do platform consolidation, but just as we've consolidated platforms, we also have to be careful that we're not going to sprawl our PaaS platforms out as well. Stepping back in time a bit, maybe the 1980s or early 90s, what we saw was many application development teams were allowed to pick any platform that they wanted, regardless of vendor support, in-house knowledge, or whatnot. It was considered a very kind of unmanaged and often unproductive period. We continue to see this in some places today, especially with small companies or places that lack architectural leadership. Typically there's a high turnover rate due to frustrated developers, testing, and ops teams. Management often does identify that there's a lack of substitutability between people, so they have 2 people doing Ruby, 2 people doing Java, 2 people doing PHP, and so on. And because these people are specialists in one particular area, they can't move them across projects very easily. It's common for each project to spend significant amounts of time to ramp up the new people, and the new platforms, and the new versions. And basically, this kind of level 1 era is most known for wasted time and money. So moving on, what we saw after that was kind of these level 2, where organizations, and mostly large companies, enterprises, moved into platform standards. What was common is that they would do an inventory of all the platforms that were being used. They'd whittle the list down to a set of recommended platforms. And I note here that it seems like that's a really simple thing to do, but what we found out is that it's highly political, where the Oracle guys don't want to lose their Oracle platform, and the Microsoft guys don't want to lose their Microsoft platform, and so on. After the politics is done, some sort of standards are created and communicated to people, and a roadmap is updated where people are expected to abide by the decisions that have been made. And often with this, there's some sort of architectural governance council that's created to help people to stay the course. So I note at the bottom here that aggressive companies initiate platform consolidation programs. And by this, what I mean is that if they had 10 different databases, they would actually make an effort to try and reduce the total number of databases down to 2 or 3 or whatever it might be, by sunsetting some of the older platforms. With the level 3 organizations, we see people moving beyond just issuing standards and having architectural governance boards to actually having some form of downloadable platform available to the end customer. And with this, it means a platform engineering team has been created. They build the platforms, they certify them, version them, patch them, and so on. Once they're complete with the platform, they make it available for download, either via some centralized portal or some other self-service fashion, and keep the documentation up to date. The binaries themselves of the platforms are usually in some sort of compressed zip format or installation file, and again, it's a separate team, typically referred to as platform engineering or something like that, that's responsible for creating those platform bits. The next stage of evolution was taking place in the late 2000s, and it's centered around this new idea of creating platform blueprints. And this is often a visual blueprint, but more specifically, it's a markup language or a set of scripts that work together to actually describe the entire platform, the modules, the components of the platform, and how they work together. This is often very characteristic of kind of the DevOps scene. So we're seeing things like Puppet and Chef and Juju and CloudFormation, and other kinds of orchestration solutions being used to automate the provisioning of some piece of platform technology. And although this is very popular, we do see some developer pushback where the DevOps tasks are related to platforms are being asked to be done by the platform teams, and the application guys basically want to focus doing DevOps tasks just for the application teams. And that kind of leads to the next era around platform as a service, which is kind of brings us up to date today. Organizations have their core platforms. They've made them available as a service. Behind the scenes or under the covers, they might be using some of those platform blueprints that we described in level 4, but that's underlying implementation detail, and it's hidden from the user, and they're not actually seeing it. They just know that it auto scales, is highly available, highly performant, secure, and so on. So the organization is continuing to use the DevOps techniques, but for application orchestration, not for that platform orchestration or platform automation. Again, that might happen under the scenes, but no one actually sees it when you're using a PaaS. So again, the platforms are exposed as SOA services, and when we're doing that, the specific intelligence of what the platform should do, whether it's in source code form, binary, or metadata, are actually being sent to the service, and they run remotely. Again, there's a dedicated set of people who might be internal individuals, meaning inside of your organization, or external in the case of a public cloud provider, that are responsible for the operations and enhancements of the platform service. Over time, what we're seeing is that multiple PaaS solutions are becoming available on both public and private clouds. They're available from different vendors, and now we've kind of moved on from this one PaaS fits all to it's actually a couple few PaaSes that people are relying on to build their applications, and we're actually seeing patterns come together where you consistently grab piece X from this platform as a service from vendor number 1 and something else from vendor number 2. On the subject of PaaS, it's easy enough to look back in time and kind of find an era that we could call PaaS V1.0, and looking at maybe where we're at today and referring to it as kind of a second generation. So with the first gen PaaS, we saw lots of solutions that made you pick a specific cloud, meaning the platform as a service would only work on one cloud. Salesforce went down this path, or they forced you into using a specific language. Originally, Heroku had you do this. They've since moved beyond that, or really just focused on startups, not kind of anyone who'd been in existence for a number of years and had legacy systems and platforms that they needed to work with. The version 2.0, or the next gen, solves many of those problems. Almost all of them are multi-language, multi-cloud, and they do let you run some legacy software, but typically when you're doing so, they drop you down to the IaaS layer and you install things on a virtual machine. Most of the good ones now have a robust set of platform services, so everything from databases to analytics to app servers and caching systems and balancers and so on. So hopefully it gives you a bit of a feel about kind of how we got to PaaS and why people have done it. Obviously, we're excited about our solution at Transcend Computing. We encourage you to learn more about our TopStack platform as a service. It does support multiple languages and is available on multiple public and private clouds, including OpenStack, CloudStack, and Eucalyptus. We are excited that, as far as we know, we're the only company who does deliver full AWS platform standards. This does enable you to burst to Amazon if you wanted, or recover to Amazon. And obviously, AWS has got some continuous innovation going, so the platform itself is not stagnating. From Transcend's perspective, we are continuing to move forward with what we would call carrier grade status on our PaaS, meaning that we're shooting for very high number of nines. We're careful in stating what we can and can't do, because quite frankly we think you have to look backward to understand what you actually have achieved versus what you hope to achieve on high availability. With that said, again, I encourage everyone to go visit Transcend Computing and take a look at TopStack. Thank you very much.